This video, we're going to look at section 7.6, solving by factoring. So we're solving quadratic functions, and sometimes they're set equal to a value other than 0, but for our purposes, we want to always set them equal to 0 for right now anyway, and find what the intercepts are. Because remember, when y is 0, that's when we hit the x-axis. So here is a graph of a quadratic function or equation where we have x squared plus 2x minus 15, as you can see on the screen. And this is the graph of that. I could graph this by just plotting some values. I could plug in a negative 5, I would get 0. I could plug in any x values and figure out what the y is. So here, if I plug in negative 1, I would get a y equal to negative 16. And you did some of that, like when you were plugging in values into a quadratic, just evaluating. That's the skill involved in this. We also could plug in 0 and we would get our y-intercept, and that would be negative 15. But it is trickier to know where your x-intercepts are. In this case, if we just kept going along, we would eventually get that. If we plugged in 3, we would find 0. But there's a very systematic way to find that. We could actually set this whole equation equal to 0, and we could factor this, and we would then get our zeros. So I want you to see what the graph looks like, and then we will talk about the workbook. One thing to note on this, if I have a coefficient of a that is greater than 0, so it's positive, I have an upward opening parabola, is what this shape is called. Okay. So now let's look at the workbook, and we're going to talk about the zero product rule. If A and B are non-zero factors, then A times B equals 0 implies A equals 0 or B equals 0 or both of them equals 0. So this is page 104 of your workbook. So just to show you some numbers here, if I had, for instance, 3 times 0, I would get 0. If I had 0 times a million, or we'll just do 100, it'll be easier, equals 0. Okay, because anything times 0 would be 0. So if one of the factors is 0, then they both are. So in, or the whole equation equals 0. So, or expression. In this case, if we had this factor here, this is in factored form, the parabola and the quadratic that I just showed you. It started off like this, so it would have been x squared plus 2x minus 15 equals 0, and then we factored it. This is factored form. And if x is 3, whoops, I can plug that in, and we'll find out that we would get 0 here times 8, and that would force it all to be 0. So a solution that we had would be x equals 3 is one of the zeros of the x-intercept. We call them the zeros or x-intercepts, okay? And that would be at the point 3, 0. That's my x, and that's my y. Now, if I had x equal to negative 5, that would also be true. I would have x minus well, actually I'm setting, this one I'm setting x equals 3. Because I can look at it and tell what it should be. I'm just eyeballing. Set x equal to -5, and that'll make this one here be 0. So I would have -5 minus 3 times -5 plus 5. That's giving me the 0. So again, if any one of these factors is 0, the whole thing is going to be 0, the whole product. So that's why it's called the zero product property. So that's going to be -8 times 0 would in fact equal 0. So x equals 5 gives us the 0.50. Sorry, -5. Be careful of that. So that's going to be -50. And if we look back at our graph real quick, we in fact have that. We have -50 there and 30 on the right. So that's when our parabola hits the x-axis. So our goal with these is to find out when x is going to equal 0. Then we can write it actually in set notation as -5, 3. This is my set notation. I'm not going to write these as intervals. These are points. This I would just say x-intercepts. So make sure it's really clear that we know it's only going to be that value when y is 0, okay? Or my x-intercepts. So that's really important. So we can solve these by factoring. And before we do that, we must have it in this format: ax squared plus bx plus c equals 0. So if it's not in that format, we need to put it in that format before we factor. And we just follow the same factoring procedure, except now we have an equation that's set equal to 0 because we're finding x-intercepts. So we have the steps here. Solve by factoring, write the given equation in this form that I just said. Ax squared plus bx plus c equals 0. Step 2, factor the left side of the equation into a product of factors. Use the zero product rule to set each factor equal to 0 and then solve for the unknown. Verify the solution. So you got to plug back in, make sure it works. So one thing here, I just eyeballed it. Right? When I was doing this, I just said, oh, if x is 3, that will make it be 0. So if I couldn't do that so easily, I would actually set the factor equal to 0. I would do x, I would actually go x minus 3 equals 0. And then I would do, get rid of that, x minus 5 equals 0, and I would solve. It's actually x plus 5 there. Okay, so down here, that's what I'm going to do, just so I can show you. But a lot of times you can see it easily if there's no coefficient. So I'm going to factor this: x squared minus 4x minus 12 equals 0. And this is why using the trial and error or guess and check or intuitive method, it's just so nice and quick because you have so many steps that you're, starting to get into. So the more you can streamline that, the better. So I know I have an x and an x to split apart to make my x squared from my first, or we say reverse FOIL too. So my last term is -12. So some options, I'm going to go for a 6 and a 2, just looking at my middle term is -4. So I should have a -6 and a +2. 2x and a negative 6x gives me the 4x. So that's good. So make sure you check it. I'm going to get rid of that just so it's out of the way. But at this point, we're starting to get more fluent. We're quicker with these, so you can just kind of off to the side or just do a quick check in your head. Most of these are going to work out pretty nicely for you because we're adding in a new skill. So the next step would be set each factor equal to 0. So I'm doing this step 3 here. X plus 2 equals 0. So if that's true, the whole thing will be 0. Or, and in math, or means and or. Because if this were a word problem, one of these might not ring true if it comes out to be negative. It wouldn't make sense if it were a length or something. So we have x minus 6 equals 0. And then I have x equals negative 2, or x equals positive 6. And then as points, these would be written as negative 2, 0. That's the x-intercept of the parabola, the graph that, a similar one to what we were looking at earlier. It's different though, but, and then we have 6, 0. And we could also write it as set notation, knowing the x-intercepts are negative 2, comma 6. Okay, and that's usually how we write our answer for these, but not always. I do want to make sure that you realize that these are points, they're x-intercepts, and that's how it works. If I were to quick graph this, just do a little sketch here, I would know that I would have an x-intercept at negative 2. I would know I have an x-intercept at x equals 6. I know it opens up and it opened like a U shape, like a smile, because A is positive and we're happy. And then I also know if I plugged 0 in, I could find my y-intercept really quickly. I could plug 0 in. I would have 0 squared minus 4 times 0 minus 12. And I could find the y value would be 12. Okay, so 0, negative 12 is my y-intercept, so that would be somewhere kind of down here. And so my whole graph would look like this. That's not my, I don't know what my vertex is off the hand, but I know that, well, actually I could figure it out. I know that it would be right, the line of symmetry would be right here, right smack in between these x-intercepts. A lot of times that's kind of overlooked, but I didn't figure out the corresponding y. We learned that in Math 99. So I'm not even going to worry about that goes over, but it would look something like that. Just to give you a scope of that, you'll learn more in Math 99 for sure. Now, this one is a little bit trickier on page 105. You have to deal with a lead coefficient of 3. So this is really great practice for factoring. So go ahead and try this one. Your classwork, you're going to factor first. Okay, so you're going to factor and then set each factor equal to 0. Okay, and then solve for x on each of those. Okay, so for the factoring on this one, I'm going to set up a 3x. That's my first term there times x. Those are my only two choices. The last term I could do a negative 4 and a positive 1, or vice versa, or I could do a negative 2 and a positive 2. Let's try and just see what happens if we do a, I'm going to write these in pink, a plus 2 and a minus 2. Just to see, just some practice here. I would get a positive 2x, and then I would get a negative 6x. That gives me a minus 4x. So that's not what I'm looking for. I need a positive x. So that's not equal to x. So this trial is out. Okay. Now, so let's try again. Let's do 3x times x. Now this tells me I need to be kind of further apart to get the numbers I want. I have opposite signs. So I'm going to try a minus 1 and a positive 4. Just looking at this, I know 7x minus 1x, that's way too big. So let's try switching those. I'm going to have a minus 4 and a plus 1. So here I get a minus 4x and a plus 3x. So I'm getting closer because I have a negative x. So now if I just adjust my signs and make this one the plus and this one the minus, I will have a plus 4x and a minus 3x, giving me a positive x. So I just wanted to review the process of factoring. But remember, these ones are set equal to 0. So we need to fit that in here, equals 0. So I'm going to set each factor equal to 0. 3x plus 4 equals 0, or x minus 1 equals 0. So now here I have a coefficient on this, so it's not so easy to see. You can do this in your head, but I'd rather you write it out if you're not sure. So subtract 4 from both sides. I get 3x equals negative 4. Divide both sides by 3. So x equals negative 4/3 for that one. Or just add 1 to both sides, and I would get x equals 1. So in set notation, as we talked about earlier, it would be negative 4/3, 1, and 1, or 1, I should say, or. So what this would look like if I were to plug it into Desmos, so you can just go to desmos.com and do any of these that you want to do. You get this little palette here, and you can just type in, I'm going to do 3x squared. I'm just typing it in as its main thing here. Let's get this out of the way. And then I have was plus x, and then I had a minus 4. Okay, make it a little bigger for you, bring it down, and then I can touch on here, and it should show me here negative 1.33. Now if you calculated out your values, you would have had negative 1 and 1/3, and that's what it would become if we crunched the numbers as a decimal. We would be rounding. And the other side is 1, 0. So that is where the intercepts hit. And then I have the y-intercept is this c, the negative 4. That'll always be the case for parabolas of this form, their general form. There's another form we use a lot called vertex form. You'll learn that in Math 99. And this is the vertex. That's the lowest point. This is because this opens up, so we have a minimum there. And again, you learn more about that later. Just want you to get a general idea what the graphs look like and where the intercepts are and why we're doing these skills. And we are going to apply them even today in this video set. So let's go back to our problem here. So again, those were the points. It was a negative 4/3, which is the same as what we had there. 0 was an x. These are our x-intercepts. And 1, 0. So that's just them written as points instead of in set notation. We have the x, y values, not just the x values. Okay, now here's a couple of cases where this actually kind of represents a parabola intersecting with a constant function. And I could figure out the points of intersection, or I could just get it into the general form and solve for my zeros. So I could set it equal to 0 first, is what I need to do if I'm going to use the factoring method. And then I'm going to factor. So I'd have a 2x and an x. That's how that splits. And then the negative 6 could split up to be minus 3 and a positive 2. Doesn't look like that's going to work out really well. So I'm going to switch those around. I'm going to do the 3 here and a 2. So I would get a, let's try a positive there and a negative here. I know I need opposite signs. So I would have a negative 3x and a positive 4x, which will give me a positive x, which is what I want up there. So good reinforcement of what you were just working on. And now I need to set each factor equal to 0 and solve. So this would be 2x equals 3, then x equals 3 halves, or x equals negative 2. If I wrote that in set notation, it looks like this. We actually want these in ascending order. Okay, so I have negative 2 comma 3 halves in my braces. So be careful, those are braces. That means set notation, not interval notation or a point or anything like that. And these are my x-intercepts of that parabola. For part B, we're going to do the same thing. We have to set the whole thing equal to 0. So try that one as classwork. And then factor, set each piece equal to 0 and solve. So pause the video and I'll write out the answer for you. Okay, so here's your answer for that one. It is tricky, so I'll go through it. But if you got it right, if you got negative 8/5 and 2, that's good. Or 2 and or 5x squared minus 2x minus 16 equals 0. We're just setting everything equal to 0. So we just want all our stuff to the left equal to 0. Then factoring is a little tricky on this one. I have a 5x and an x and my only two choices for the firsts. And then for the lasts, I tried 4 and 4 and that just wasn't working for me. So I looked at an 8 and a 2 here, because then I would have a negative 10x plus 8x. And that gives me the negative 2x I need for that middle term. So then I set each factor equal to 0 and I get x equals negative 8/5 or x equals 2. All right. Now these types are a lot trickier. I filtered out most of your homework for you. I'll do one with you, but then we'll just skip the rest. We do this more in Math 140. A lot of times these textbooks kind of have multi-levels inside them. So the first thing, if we don't have it set equal to 0, is we would have to set it equal to 0. And this one's a little more complicated because I have to distribute first. So I would do this as 2x squared plus 8x. And then I would have to subtract that 3x and add the 3, set it equal to 0. You could take that in stages if you wanted to. Then I have 2x squared plus 5x plus 3 equals 0. And then I go ahead and factor. I'm just double checking my math here. 2x squared plus 8x minus 3x plus 8. Okay. So I have 2x times x equals 0. And then I would have my ends being a 3 and a 1. Let's try 3 and 1. So I would have a 1x and a 6x. That's going to give me a 7x. So I'm running into trouble there. So let's try switching it around. Do a 3 and a 1 like that. Then I get 3x up plus 2x. That's awesome. I get 5x. That's what I need. So now I'm going to set each of those factors equal to 0, just like I've been doing. 2x plus 3 equals 0, or x plus 1 equals 0. So now I have 2x equals negative 3. So therefore x equals negative 3 halves, or x equals negative 1. Just to quick write that in my set notation, I would have negative 3 halves, comma, negative 1 in braces. And those are representing my x-intercepts. Okay. This one we can skip if you wanted to try. I mean, you'd have to FOIL this out and then set everything equal to 0. It does get a little tricky. All right, here's one that I do want you to take a look at. Example 7.36. We would have 4x squared equals 12x. So we're going to subtract the 12x from both sides. There's a couple of different ways we could attack this, but then we could factor out a GCF. So we have 4x. And then we have x minus 3 as our other factor. So sometimes you don't have a binomial as one of your factors. It's just a monomial. So again, just set that factor equal to 0. 4x equals 0. Or x minus 3 equals 0. So this is really nice because 4x equals 0. That just means x equals 0. Divide, if you divide both sides by 4. Sometimes this throws people off. They haven't done it in a while. Anytime you have 0 in a numerator, you're going to have 0 as an answer. And then here would be, or x equals 3. And that's the set notation. Now, in your MyOpenMath, you're going to need to just really look at what they're asking the format to be given in. They might have it be this format. They might have it be in set notation. They might actually ask you sometimes to write it as points. So this would be as points. Remember, your y is always 0. So for x-intercepts, y is always 0. Okay. That's a broad concept that we always want to kind of keep in mind. For B, we need to factor out a GCF of x squared or just x first. And then we have 3x squared minus 8x minus 35 equals 0. Then we can factor again. We have 3x and x. And if you want to pause the video and try that one on your own, this would be a good one. But if you want to just continue with me, that's cool. So 35, my options, probably not 1 and 35. I'm going to try 5 and 7 and see how that goes. If I have, I'm going to say probably a 7 here and a 5 here. I know I need to have the sign attached, the negative attached with the bigger one. So let's try, and I know I need opposite signs. So I'm going to try 3x plus 7x minus 5. Let's see how that goes. I have a positive 7x and I have a negative 15x, which does give me my minus 8x that I need. So that's good. Then I'm going to set each factor equal to 0. Don't forget about the x. You got to bring that down. X equals 0, or 3x plus 7 equals 0, or x minus 5 equals 0. So our answers would be 0. We would have negative 7 over 3. You could actually, might take time to do that out. Or we would have 5. So those are getting a little trickier. So if in your MyOpenMath, you do have video tutorials to help you with that. Okay, that's the end of part 1 of this video set that covers the skills of solving by factoring. In part 2, we're going to look at just a couple of problems solving applications by factoring, but they're going to take a little longer to do. So I want to separate those out. That's section 7.7. And I kind of put these together. Remember, Math 99, you're really going to dive deeper into this. This is just introductory. So if it's really tricky and it's hard, I'm not going to test super heavily on your quizzes, tests, and finals that's remaining. But for Math 99, you want to be really ready. You'll be very prepared if you can even get, a good chunk of this down, just being able to see it again. My neighbor has a motorcycle, sorry, so revving up. So have a great day.